Welcome to the Java Fundamentals course, where we're going to learn about the basic mechanisms and features of the Java programming language. My name is Boško Bezik, and I'm going to be your instructor. In order to become a successful Java developer, you will need a strong foundational knowledge of the Java language and platform. I'm assuming you know nothing about Java, and we're going to cover everything from scratch. However, if you are an experienced developer who is looking to switch to the Java platform, you're free to skip ahead into parts of the course that are of interest to you. This course will have timestamps to make it easy to track lessons. In this course, I explain Java fundamentals, which includes data types and variables, operators, arrays, conditional statements, loops, effective code practices, and debugging and deployment. As we go along with the course, I will do my best to explain all the concepts, mechanisms, tools, and terminology by going through practical examples. At the end of every section, there will be exercises so that you can apply what you've just learned. I highly encourage you to finish these exercises because they are the real moneymaker. The more you practice, the better you will retain the knowledge. My goal is to make learning simpler and easier for everyone. I will not only teach you about the Java language, but I will also share tips and tricks that I've accumulated over the years as a professional software developer. I have a coding school at bestboss.com where you can find more courses to expand your skill set and turn yourself into a highly sought-out software developer. I hope you're ready. Let's get started. Java has been around for a long time and has been the driving force in the IT industry. It's one of the most popular and sustainable programming languages ever created. If you take a look at this programming language index from tiobe.com, which is a popular index for checking programming language popularity, we can see that Java has consistently remained among the most popular programming languages. The reason Java is so popular nowadays is because it has a healthy ecosystem of libraries and learning resources that you can use to build production-ready applications that can address even the most complex business needs. Another reason is that it makes development easier by providing a managed runtime. Java does automatic memory management and garbage collection, which saves us a lot of work. Java was designed with portability in mind, allowing you to write your code once and run it anywhere. You could write an application and run it on Windows, Mac, and Linux. You can also run it on x86 and ARM CPU architectures. Java is also the primary development language for the Android platform. Another principle that Java was designed around is code readability. If you think about it, you will spend more time reading code than actually writing it. So it's important for a programming language to have syntax and mechanisms that allow us to write readable code. Java has been careful with introducing new features. You could take Java code from 10 years ago and run it with modern Java and it would work. Java is open source and there are multiple distributions of the Java platform available. You could download the JDK built by Azure, Amazon, or Microsoft and use their distributions to run your Java code. It's easier to optimize readable code than it is to improve readability of optimized code. Java is more than a programming language. It's actually a platform. The Java platform consists of three primary components: the Java programming language, the Java virtual machine, also known as the JVM, which represents the runtime environment where the Java code is executed, and the Java standard library, which contains commonly used data structures and functionalities for writing applications. These three components are enveloped in what's called the Java Development Kit, also known as the JDK. As the name implies, the JDK contains all the tools you need to build and run Java applications. Older Java code was more imperative, meaning that you had to write a lot of boilerplate code for basic tasks like filtering a list or mapping objects. Modern Java is more declarative and makes it easier to implement complex business logic. A common misconception about Java is that it's somehow related to JavaScript. There is actually no relation whatsoever between Java and JavaScript. They are two completely different programming languages and don't share anything except the word Java. Before we do any coding, we need to install Java on our machine. There are many ways of installing Java, but I'm going to show you the simplest one. First, I'm going to show you how to install it on Windows and Mac, and then I will cover the Linux installation. Let's open the web browser and visit oracle.com/java/technologies/downloads. I'm going to decline the cookies because I don't really care about them. From this website, we can download the JDK, which is the Java Development Kit. We can download the latest distribution or the long-term support distribution, LTS for short. Java maintains very strong backwards compatibility, so it doesn't really matter which version you're going to install, as long as it's Java 8 or newer. I suggest you to download the latest version. At the time of this recording, the latest Java version is 19, so I will download that one. When you watch this, it might be Java 20 or Java 21, it doesn't really matter. I'm going to pick Windows, and I'm going to click the x64 installer option. It's going to take a while, so I'm going to skip ahead. The download is finished. I'm going to run the installer. Keep clicking Next. And it's done. Now we just need to verify that the installation was successful. We can do that by opening the command prompt. Open the Start menu and type cmd. Open the command prompt. Type in java-version and press Enter. There we go. We've successfully installed Java on our Windows machine. Next, let's install it on a Mac. I'm going to open the terminal. Increase the font size. Type in Java, and this should bring up a prompt. You want to click on the More Info button. This will open the JDK downloads page on the Oracle website, or if this doesn't work, you can just visit it yourself. I'm going to select Java 19, pick the x64 DMG installer file. This will take a little while, so I will skip ahead. The download is finished. I will now open the downloaded DMG file by double-clicking on it. Wait for verification to finish. Now we open the JDK package file. The installation is very simple. We click Continue and Install. Enter the password. And that's it. We can verify that the installation was successful by going into the terminal and running java-version. Next, we're installing Java on Linux. We could also install Java from Oracle's website, but I wouldn't recommend that on Linux distributions. Instead, we should use package managers to install Java. On Fedora, you can use DNF to install packages. You can simply run this command. On OpenSUSE, things are a bit more complicated. Due to Oracle's licensing policies, the Java runtime cannot be included in the repositories of OpenSUSE anymore, so you can't just run one command to install Java. However, OpenSUSE does provide a guide on how to install Java in a different way, so you can still install Java, but it's more difficult. On Arch Linux, there is a utility called Arch Linux Java for installing and managing Java versions. On Red Hat Enterprise Linux distributions, you can use yum to install Java. If you are a Gen 2 user, you can follow this guide to install Java. Now, since I'm running KDE Neon, which uses Ubuntu as its base, I can use apt to install Java. I'm going to open the terminal, go full screen, and make the font bigger. First, I will make sure my apt repositories are updated, so I will run sudo apt update. After that, I will search the repositories for the Java Development Kit, type in sudo apt search open JDK. We can see all the available JDK packages. Now, there are a lot of them here, but I only really care about OpenJDK 19. So I'm going to install that one. Of course, you can install older or newer versions, it doesn't really matter. Back to the bottom of the terminal, type sudo apt install openjdk-19-jdk, press enter, type in Y to continue. Now it's going to take a while for it to download and install, so I will skip ahead. Alright, the download is finished. Let's run java-version, and it prints out our Java version. Very good. If you want to switch between different Java versions, you can follow this guide. But basically what you have to do is first have 2 or more JDKs installed. Then you can run this command, sudo update alternatives --config java. This will bring up an interactive prompt menu. Here you can see which JDK is currently selected, and you can choose a different one. I'm going to briefly switch to Java 17. Check the version. We can see it really did change to Java 17. Now let's go back to Java 19. There we go. We're going to be using IntelliJ IDEA as our code editor. As a matter of fact, IntelliJ is more than just a code editor. It's what's known as an integrated development environment, IDE for short. It's arguably the best IDE for Java, and it's absolutely free. First, I'm going to show you how to install it on Windows. I'm going to open up the browser and go to jetbrains.com/idea. Go over to the download section. IntelliJ has 2 editions. There is the Ultimate Edition, which comes with additional tools for web development, but it's not free. Then there is the Community Edition, which contains all the core tools for Java development. Although the Ultimate Edition has additional tooling, you don't really need it unless you're going to be doing web development with Java, and even then, I would argue you could do just fine with the Community Edition. We're going to download the installer. This might take a while, so I'll see you in a bit. The download is finished. Let's run the installer. The installation process is very simple. You just keep clicking next. This installation directory is fine. You should check this option that says add bin folder to the path. This will add the location of the IntelliJ executable to the path environment variable, which will allow you to run IntelliJ from the command line. I'm going to let it install. Rebooting is not necessary, so we're just going to finish the installation. Let's run IntelliJ to confirm it's working. Agree to the terms. Pick whatever you prefer here. It could actually help JetBrains to make IntelliJ better. Personally, I don't like having my software send any usage data unless I explicitly ask it to, so I will pick Don't Send. You can always change this option in settings. There we go. We've successfully installed IntelliJ on Windows. Now let's do the same on Mac. I'm going to open up the web browser, visit the IntelliJ IDEA website, go to the download section. Here make sure that macOS is selected. Make sure to pick the appropriate DMG file download. If you have a newer MacBook, you're probably running on Apple Silicon. I have an older device, so I will pick the Intel option. Allow the download from jetbrains.com. This will take a while, so I will skip ahead. Let's open the DMG file. It's going to verify it. drag the IntelliJ icon into Applications to install it. Open the Launchpad and find IntelliJ. Run it. It's going to verify it once again. Click Open. Accept the terms. Don't send statistics. And there we go. We've successfully installed IntelliJ IDEA on our Mac. To install IntelliJ on Linux, you have two choices. You can use Snap or Flatpak, which is the simplest approach, and I recommend you to do it this way. Alternatively, you can download a zipped archive containing the IntelliJ binaries. This is a more complex approach as it requires manual setup. Snap and Flatpak installations are pretty simple. You copy and paste the snippet for installing IntelliJ and you're done. Of course, just make sure you have Snap or Flatpak clients installed on your system, otherwise these won't work. For those who don't want to use Snap or Flatpak, I'm going to show you how you can install IntelliJ manually. Let's start by downloading the zipped archive. If you are on a device that has an ARM64 chip, select the ARM64 option. I'm going to put the archive in my Downloads directory. I will skip ahead to when the download is finished. Let's extract the archive contents. When that's finished, let's open the extracted directory and open the installation instructions. Okay, the first step says to unpack the archive, but we already did that. So I'm just going to move IntelliJ into my home directory. Ctrl-X to cut, Ctrl-V to paste. Next, it's telling us how to start IntelliJ. I'm going to open up the console in this directory. Change into the bin directory, run ./idea.sh, and IntelliJ starts up. It opened on my second display. Let me bring it here. So this is good and all, but every time we want to start IntelliJ, we will have to open the terminal, change into the IntelliJ bin directory, and run it from the terminal, which is very tedious. Now, we can do something to make this better. First off, let's allow IntelliJ to be opened from the terminal by just typing in idea.sh. This way, it doesn't matter in what directory we are, we will be able to run IntelliJ. To do that, let's go back to our home directory, cd tilde, which is just an alias to the home directory. Open the .bashrc file in your editor of choice. I'm going to use Vim. Go to the bottom of the file. Here I'm going to append the path environment variable with the location of the IntelliJ bin directory. This way, whenever we start a new bash instance, we will be able to run idea.sh to start IntelliJ. Write changes and quit. And now, if I open the terminal again, I will be able to run IntelliJ by simply typing idea.sh. That's much better, but we still have to open the terminal to start IntelliJ. We can do better than that. Since I'm on KDE Neon, I'm using the KDE Plasma desktop environment. That means I can easily add a program to the Applications menu. So let's bring up KRunner by pressing Alt and space. Search for Menu Editor. In the Menu Editor, we can easily customize the applications in our application menu. I'm going to open the Development submenu. The existing IntelliJ entry is actually the IntelliJ that I previously installed with Flatpak, so just ignore that. Click on New Item. I'm going to call it IntelliJ IDEA Manual to discern it from the Flatpak IntelliJ installation. Okay, let's add the path of the idea.sh script. We can also add an icon. I'm going to browse for the icon in the IntelliJ directory. Pick the SVG icon because it scales better. Press Ctrl and S to save. And if you open KRunner or the application menu, you will find the new IntelliJ shortcut. Now we can simply click on it and it opens in the background just like any other program. If you're using a different Linux desktop environment like GNOME or XFCE, I'm sure there is also a way to add IntelliJ to their application menus. This concludes the installation of IntelliJ on Linux. I'm going to show you how to create a new Java project in IntelliJ. So I'm going to open IntelliJ through KRunner. If you're on Windows, you can do the same through the Start menu by pressing the Windows key and typing in IntelliJ, or on Mac by opening Launchpad and looking for IntelliJ. We're prompted with a welcome screen. You can do some general customizations here, like changing the theme, font size, color accessibility, and key map. This is the font size of interface elements, and I've set it to 30 points for presentation purposes. I suggest you to leave the default font size or increase it slightly if you have difficulty reading. The key map represents the keyboard shortcuts. Yours will be different depending on the system you're running. I suggest you leave this as it is unless you're sure you want a different key map. You can install plugins which allow you to extend the functionality of IntelliJ, like adding language and framework support and so on. You don't have to do anything here. I have additionally installed Presentation Assistant so that you can see what keyboard shortcuts I'm using. IntelliJ comes with some pre-installed plugins like Kotlin and Groovy language support. Here you have links to some IntelliJ learning resources if you're interested in that. I'm going to create a new project. Give it a name Java course, but you can call it something else. It doesn't really matter. I'm going to place it in ~projects. The tilde symbol resolves to the home path of the current user. In my case, that's /home/Boško. Make sure that Java is selected as the project language. For our build system, we're going to be using Maven. The build system is what will build our Java programs for us, sparing us some time and effort. Nowadays, all projects are built with a build system, usually being Maven or Gradle. Honestly, it doesn't matter which one you pick, since we really won't be using much of it for our purposes, but I'm going to use Maven because that's the most commonly used build system. Now, because I'm running IntelliJ as a Flatpak application on Linux, that means it's sandboxed, so it can't find the JDK I've previously installed. I'm going to have to use IntelliJ's built-in JDK downloader. Here you can pick almost any version of Java you want. I'm going to pick 19 and Oracle OpenJDK. There are also a bunch of different JDK distributions you can choose from. Generally, it doesn't really matter which one you pick, but I prefer using Oracle's OpenJDK or Azul JDK, which I already have previously installed under version 17, but I will install the new one. Alright, the download has finished. Make sure this option is turned off, since we want to start without any sample code. I'm going to expand Advanced Settings. Another thing you can do here is change Group ID and Artifact ID. These two represent the root package name of your project. The Group ID represents the name of your organization or your personal website, but with a reversed domain name. Of course, it can be anything you want, but that's generally what's used for the Group ID. The Artifact ID represents the name of the project, so it should be same as your project name. So I'm going to type in com.bezboss. Artifact ID is going to stay the same. Click Create. Now, since this is the first time we're opening a Java project, IntelliJ needs to do some indexing. Indexing is the process where IntelliJ creates indexes about various Java packages and their contents. These indexes are used by various IntelliJ features like code suggestions, auto-completion, searching, and so on. IntelliJ might ask you to download pre-built indexes for the JDK. You can use this to make indexing faster, but on modern machines this is already pretty fast, and it happens only when you open a project for the first time. Subsequent openings of the same project will be much faster. Before we continue, I just want to change the user interface theme to the new design that IntelliJ has recently released. You don't actually have to do this, and you will be following perfectly fine without it. but I want to share this with you because that's how I like to set up IntelliJ. Open the settings by pressing Ctrl, Alt, and S, or you can go to Files and then Settings. My UI font size is much larger than normal because I'm recording. My font of choice is Noto Sans. It's a free font that you can easily download. This is where you enable the new UI design. I'm going to enable it and apply changes, which will require a restart. I think this looks better. The interface is cleaner and it's easier to understand. Not that IntelliJ had a bad interface, as a matter of fact I would say it's the best looking IDE out there and now it's even better. Another thing I will change is the code editor font. The default font is good, but I prefer to use Fira code or Cascadia code. Both of these are free fonts that you can easily download. When we created this project, this pom.xml file was automatically opened. This file contains the configuration of our build system, Maven. Here you can find properties that we've set when we created the project, things like the Java compiler version, group ID, artifact ID, and project version. You will also find definitions of various project dependencies, but we don't have any dependencies added to this project. On the left side, we have the Project Explorer window. Here we can see the structure of our project. I'm going to explain to you what each of these directories and options mean. The .idea folder contains the configuration files that are exclusively used by IntelliJ and its plugins. So if we were to open one of these files, we can see it's just a bunch of configuration options that are read by IntelliJ or its plugins. If you had opened this project inside Eclipse or Visual Studio Code, you would see folders like .eclipse or .code, which would contain their configuration files. Inside the source directory is where all of our code and assets will be located. Further down we have the main and test directories. The main directory will contain our program code and assets, but the test directory will contain code and assets exclusive to unit tests. Inside the main directory we have Java and resources. Java is where all of your code will be located, while resources is where you will store application assets that you might have in your web application or desktop application. Generally things like property files, XML, HTML, CSS, JavaScript, images, and any other file you want your application to load during runtime. In test, there is no resources directory by default, but you could create it if you need it. The pom.xml is located in the root of our project and represents the configuration of our build system Maven. In its basic form, Maven is a tool that manages dependencies and build processes of our project. In a few moments, I'm going to build and run our little project, and you will see some things that Maven did for us. In the external libraries, you can see all the libraries that your project uses. A library represents compiled Java code that somebody decided they want to share. Usually this code is packaged inside a jar file. This file is added to your Java project class path and you can use its classes and methods inside your project. Dependencies represent outside packages that your project depends on. Maven manages dependencies by checking which ones are listed in the pom.xml file. If it finds any dependencies, it will download them and add them to the class path. Here we can also see the JDK as a library. It's listed here for convenience and allows you to easily access definitions of Java classes should you need to see their contents. For example, let's see the source code of the built-in HTTP client. Note that all these files inside the JDK contain Java bytecode, but since IntelliJ has a built-in bytecode decompiler, we can see the actual source code. IntelliJ is letting us know that it's rendering the comments inside the code for easier reading. We can actually turn it off if we want to see the comments as they are. I will explain what comments are later. I'm just going to put it back into reader mode. So yeah, IntelliJ allows you to effortlessly peek inside the source code of compiled Java classes. Lastly, we have scratches and consoles. This is very useful when you want to take notes. You would need to create a new scratch file though. I'm going to look for a text file. Whenever IntelliJ prompts you with a selection menu like this one, you can just start typing the name of whatever you're looking for and IntelliJ will filter out the items that match your query. This is one of many productivity features within IntelliJ, and I'm going to explain more of those as we go along with the course. So now that I've created this Scratch file, I can write down a note inside of it, like a to-do as a reminder. These Scratch files are not part of the project and they're located somewhere else, so you can do whatever you want here and it won't break your project. Alright, so I'm going to create a new Java class and write a small program that prints out Hello World in the console. So right-click on Java, New Class, and it's asking me for a class name, so I'll name it Application, which is a classical name for a class that contains the entry point of a Java program. Press Enter, and here is our class. So now we just need to define the main method, which indicates the entry point of our program. So we write public static void main, open a pair of parentheses, string, pair of brackets, args, open a pair of curly braces, system dot out dot println, which stands for print line, open a pair of parentheses, and in double quotes write hello world, and at the end of the line we place a semicolon which indicates the end of the statement. Now I want to run this program, and IntelliJ is smart enough to recognize that this is the entry point of our program. So it put this small play button here which you can use to run this program. And here is our hello world message. If for some reason you're not getting the play button here, you probably didn't write this method properly, or perhaps you didn't install the JDK properly. You can also manually run the project by going to Run Debug Configurations and Edit Configurations. For me, IntelliJ has already added a run configuration, and yours should look like this as well. If you don't have it, you can go here to this plus sign, select Application, give it a name, make sure a JDK is selected, give it the name of the class that contains the main method, and click OK. So now you should be able to run the project. In IntelliJ, we have snippets, which are prepared lines of code that help you code faster. So instead of typing out the main method by hand, you could just type main, and you will see how IntelliJ suggests the main snippet. Then you press Tab, and IntelliJ generates the main method for us. There is also a snippet for system out print line. You will notice a bunch of other text that was printed out that we didn't specify in our program, so I'm going to explain what each line means. First, here is the Hello World message that was printed out. This was from the code that I wrote. Now we have this long line of text on the top of the console output. This line was generated by IntelliJ. It's basically a command that was executed in the command line interface, and this command runs our Java program. IntelliJ generates this command for us so that we don't have to write it manually. So this first part of the command is specifying what program we're running. In our case, it's going to run Java, which is located in the JDK directory. The -Java agent parameter is adding an IntelliJ component to our program which allows debugging. The -d file.encoding parameter specifies the default character set to be used when reading and writing files. The -class path parameter specifies the location of compiled Java classes, basically the build location of our project, where all the project generated bytecode is located. So you can see that there is this target directory which wasn't there before. It was created when the project was built. If we open the classes directory, we'll see application is there. But this is not application.java, this is application.class. It's a different file, and this .class file contains Java bytecode. IntelliJ can decompile this bytecode into Java code. And as we can see, it's the same code that we wrote in the application.java file, except for the constructor method, but I will explain those later. Generated sources contains bytecode that was generated by external tools. Lastly, the application parameter is just the name of the entry point class, which is the class that contains the main method. So we could actually take this command and run it ourselves in the command line. Press Alt and space to bring up KRunner, search for terminal, maximize it and increase the font size. Paste this and run it. Well, I will actually get an error because I can't open the IntelliJ instrumentation agent or something. As a matter of fact, we don't need most of these flags, so I'll remove the unnecessary parts. Run it again, and there is our Hello World message. Now, I've just used the Oracle OpenJDK that IntelliJ had downloaded for me when I created the project. Since I installed Oracle OpenJDK on this system and it's been added to the path variable, I could just write Java and that's going to run our program as well. So this is basically what IntelliJ did for us. It generated and executed this long and complex command, and believe me, it gets much bigger for real-world projects out there. But before IntelliJ generated this command, Maven had built our project, taking our Java source code files and passing them to the Java compiler, which generated the .class files containing bytecode, which the JVM compiles into machine instructions, which are then executed on our machine. This line just indicates that our Java application has connected to a debugger, and this one indicates that it has disconnected from the debugger. This final message is something Java prints out depending if our program had a fatal error or not. So if our program executed properly, the status code will be 0. Any other status code indicates our program didn't execute properly and had errors. Usually you won't really look at this status code because there are better ways of telling how your program crashed by looking at log messages and stack traces, but it's good to know this nonetheless. Java is a programming language that was designed with portability in mind. A common slogan used for Java is "Write once, run anywhere." Programming languages like C++ or Rust are compiled ahead of time, meaning that the language is compiled directly to machine instructions for a specific CPU instruction set architecture. This approach provides performance benefits but limits program portability. A C++ or Rust program that is written for Windows will not run on Linux without being recompiled for Linux. The same issue applies to instruction set architectures. A program compiled for x86 CPUs will not run on ARM CPUs. Java addresses this issue by compiling Java source code into intermediate instructions, called bytecode. This bytecode is then shipped to the Java virtual machine, which then compiles the bytecode into machine instructions for the current system, thus providing you with the ability to write once and run anywhere. The process of compiling bytecode into machine instructions is also known as just-in-time compilation, or JIT for short. Although this approach does introduce some performance degradations, especially on program startup, modern JVMs have JIT compilers that can analyze hotspots in the code and additionally optimize these code paths during runtime. There is also the Graal VM Java compiler, which precompiles and optimizes Java code and packages it inside a container, which allows for much faster startup, lower memory consumption, and generally much better performance. Because the JVM compiles bytecode to machine instructions, this means that it's also possible to have other languages generate bytecode and have that bytecode get executed on the JVM. Because of this, there are already a few popular JVM languages such as Kotlin, Groovy, and Scala. You could write a program in Kotlin that calls methods from Java and vice versa. Alright, we're done with the Getting Started section. After each section, I'm going to give you exercises and/or quizzes to complete. You are expected to pause the video and try solving the exercise or answering the question. The question and answer screens will only be displayed for 5 seconds each. Please do not skip exercises and quizzes. Try completing them at least once. This is very important for stimulating a learning breakthrough. Now let's get started. Hey there! I just wanted to let you know that you don't have to memorize everything you see in this course. You can always come back and re-watch the important sections. But I have also compiled a cheat sheet document that contains everything that I talk about in this video. This way you can easily remind yourself of certain concepts and mechanisms. I've put a lot of effort into creating the best Java course I possibly could, and I would really appreciate it if you would support me by liking and sharing this video. Also, be sure to subscribe and enable the notifications, so the next time I upload something interesting, you will get notified. Thank you so much, and let's get back to the course. In Java, we use variables to store values. Each variable has a name, data type, and a value. You can imagine variables as boxes where each box is labeled with a name and the type of its content. You can take each box and put something inside of it as long as it corresponds to the content type that box is determined for. It's the same with variables. I'm going to create 2 variables for storing numbers and one to store text. Int a is assigned 1, int b is assigned 2, string c is assigned hello surrounded by double quotation marks. Double quotation marks are used to denote strings, which is basically how we represent text in Java. The first part of a variable is its data type. In this case, we have 2 integers and a string. The next part represents the variable name. In this case, we used very simple names like a, b, and c. The equals symbol is the assignment operator, and it's what we use to assign values to variables. The numbers 1, 2, and the string hello represent literal values. Lastly, the semicolon symbols are used to denote the end of statements in Java. In Java, variable names are case sensitive, so if I had 2 variables with the same name like this, string silver is assigned silver, string silver but in uppercase is assigned silver. This would be 2 separate variables because one is in lowercase and the other one is in uppercase. We can access variables by writing their exact names. So, silver is assigned gold. In this case, I reassigned the value of the variable silver so it has a new string value, gold. Since variable names are case sensitive, that means when we access the variables, we have to write the exact variable name, otherwise we will get a compilation error. So if I try to write silver with a capital S and assign silver, this won't work. If I try to assign silver with all capital cases, this would work. And if I try to assign silver with all lower cases, this will work. And that's because we have these 2 variables, silver with uppercase and silver in lowercase. But we don't have silver that starts with a capital letter. Variables in Java are named using the camel case convention. That means that variable names begin with a lowercase letter, but each preceding word begins with an uppercase letter. String, silver description text, is assigned, silver is a precious metal. So this is a correct way to name a variable in Java. This one is not correct, and neither is this one. There are other variable naming conventions that are used in different programming languages, But in Java, we almost exclusively use the camel case notation to name our variables, unless we're naming a constant, in which case we use the so-called screaming case notation. Static final int silver underscore ID is assigned 100. So this is correct when naming constants. So we've declared some variables and assigned them some values. Variables can be accessed inside expressions and used for arithmetic and logical operations. For example, we can take two integer variables and add them together, then store the result inside another variable. Int result is assigned a plus b. We can also do this. Result is assigned a plus result plus 10. So what we did here is we added a with result and added 10 to it, then assigned the result of that expression into the result variable. Let's print out the result in the console. System out println result concatenated with result. So we can use this println method to print out stuff into the console. Press Shift and F9 to build and run this project, and there is our result. Note that any number variable that you pass into the println method is automatically converted into a string. So when we say result is concatenated with result, the result variable is converted into a string, and the two strings are joined together. I'll explain this in detail once we talk about typecasting and conversion. We can prevent variables from being reassigned by using the final modifier. Final double pi is assigned 3.14. The data type double is used to represent fractional numbers. The keyword final before the data type is the modifier that prevents this variable from being reassigned. Pi is assigned 3.1415. So this code won't compile. We're getting a compilation error, cannot assign a value to final variable pi. This modifier prevents variables from being reassigned, which effectively allows us to create constants like pi. The final modifier is very useful when we want to ensure that important variables do not get reassigned, which might not seem significant at the moment, but it's actually a very useful mechanism for preventing unexpected state changes in our application. I would like to clarify some commonly used terminology. This isn't exclusive to Java, and all of these terms are used in other programming languages. First, we have expressions. An expression is any reference to a variable or value or a set of variables and values combined with operators. For example, int a is a variable declaration expression. A assigned 2 is a variable assignment expression. A plus 3 is an arithmetic expression. 2 is a literal expression, and so on. The important thing to remember is that expressions can be chained together to form a statement. A statement is a set of one or more expressions. Int a is assigned 1. So here we have a declaration expression, a literal value expression, and an assignment expression. Together they form a statement. Code can easily become complicated, and it can be difficult to understand what certain pieces of our code do. We can use comments to provide hints and explanations for these parts of our code. Comments are ignored by the compiler, so they cannot affect the program's logic. In Java, there are three types of comments. First, we have single-line comments. // this is a single-line comment. Single-line comments are generally used to write small notes and hints, although you can stack them up and write a paragraph if necessary. However, if you need to write so many comments, you might as well use multi-line comments. /*, this is a multi-line comment. //. The third type of comment is called JavaDoc, and it's used to document methods and types. If you hover over a method or type, IntelliJ will show you quick documentation. You can also click on a method or type and press Ctrl and Q to bring up the quick docs. The documentation you see here is actually written using Java doc comments. Java doc is very powerful because it allows you to extensively format your comments, and you can even export all the Java doc comments from your project into an HTML file. I'm going to add a Java doc comment to the main method, /*, the entry point of our application, at params args program arguments /. Now, if you bring up quick documentation for the main method, you'll notice that your comment shows up as documentation. At the core of every programming language are the primitive data types, which consist of integers, floating point numbers, characters, and Boolean types. There are also reference data types, which represent objects, but they work a bit differently. Let's start with primitive number types. The smallest number primitive is byte. It takes 8 bits of memory and can represent a number between -128 and +127. Byte number is assigned 100. Now, you're probably wondering why the maximum byte value is 127 and not 128. That's because in programming, 0 is considered a positive number. This is why in programming languages we count from 0. Next is the short number primitive. These take up 16 bits of memory. Short number is assigned 20,000. You can always check the maximum and minimum values for a primitive number by accessing a constant on its equivalent type. Min short is assigned short.min value. Max short is assigned short.max value. System out println minimum short is concatenated with min short. In IntelliJ, you can press Ctrl and D to duplicate the current line. System out println maximum short is concatenated with max short. We can do the same thing to get maximum and minimum values for byte, but I'm not going to type out the code. Instead, I will copy and paste the previous code and simply change it. In IntelliJ, we can simultaneously select multiple occurrences of some text and replace it. You do this by selecting a piece of text you want to match and press Alt and J. And while holding down Alt, each press of J will select the next occurrence. Next, we have the integer number primitive. Integers take up 32 bits of memory to represent pretty big numbers, and they are the most commonly used numeric type. Let's declare an integer. Int number is assigned 1,200,300. Let's see the minimum and maximum integer values. Next, we have the long number primitive. Longs take up 64 bits of memory to represent very large numbers. Let's declare a long. Long number is assigned 100,200,300,400 L. When declaring longs, we have to apply the suffix L to the literal value. Otherwise, the compiler will store the value as an integer, unless the value cannot fit in 32 bits. In that case, you'll get a compilation error. For example, long without suffix is assigned 1,200,300. System out println long without suffix is concatenated with long without suffix. That works fine, but once we assign a value that doesn't fit into 32 bits, the compiler would complain, so it's always best to apply the else suffix to long values. Let's see the minimum and maximum long values. So far, these have been primitive types for representing whole numbers. If you're coming from a background of other programming languages, you may have noticed I haven't mentioned unsigned integers. That's because Java doesn't have unsigned integers. If you need to represent an unsigned integer, it's best to use the long primitive as it can easily store the maximum unsigned integer value. Next, we have the Boolean primitive, which is used to represent if something is true or false. Boolean needs only one bit to represent its value. However, its size isn't defined by the Java language specification. So it's most likely going to take up anywhere between 8 and 32 bits for the sake of optimization. Let's say we need to represent an account status. We could define it like this. Boolean is account enabled is assigned true, or if we name the variable differently, Boolean is account expired is assigned false. Next up is the character primitive. In Java, characters take up 16 bits and represent a single Unicode character from the UTF-16 table. For example, character letter A is assigned a character A. Notice that in Java, characters have to be surrounded by single quotation marks. Let's write more characters and print them out. Character number 1 is assigned character 1. Character Greek letter gamma is assigned the character G. Character electricity sign is assigned the lightning emoji. And we print them out. So as you can see, just about any character from the UTF-16 table can be used in Java. We've seen how to represent whole numbers, but now we're going to cover floating point primitives, used for representing decimal numbers. First is the float primitive, which takes up 32 bits of memory to represent decimal numbers, and they are accurate up to 7 decimal digits. Float number is assigned 1.123456 f. Float values have to be suffixed with f, otherwise you will get a compilation error. That's because all floating point numbers in Java are considered as doubles by default, but doubles take up 64 bits, so they can't fit into a 32-bit float. Let's take a look at minimum and maximum float values. Float max float is assigned float.max value. Float min float is assigned float min value. System out print line minimum float concatenated with min float. System out print line maximum float concatenated with max float. Next is the double primitive, which takes up 64 bits of memory to represent decimal numbers and are accurate up to 17 decimal digits. Double number is assigned 1.123456789 so that's 17 decimal digits. Doubles can be suffixed with D, but it's not mandatory because in Java all decimal numbers are considered as doubles by default. Let's take a look at minimum and maximum double values. Although floating point data types are used to represent fractional values, you shouldn't use them for monetary calculations. This is because of how floating point arithmetic works and how it rounds numbers. Explaining floating point nuances is beyond the scope of this course, but just know that if you need to do monetary calculations, you should not use floats or doubles. Let me show you why it's a bad idea to use floating point types for monetary calculations. Here's an example. Let's say we have two doubles with really small fractions and we decide to add them together. The expected result is 1 point, a bunch of zeros, and then 25. However, it got rounded to 1, which means that we've lost a small fraction of the value. Let's consider you have two financial transactions where fractional values are greater than 17 digits. If we store the amounts as doubles, all digits after the 17th digit would be truncated. This would yield an inaccurate result. Now, this wouldn't be an issue if this happened once or twice, but imagine if someone wrote a program that did monetary calculations like this for a few years. Now that would be a problem. So instead of using floats or doubles, we should use the big decimal data type. Big decimals can preserve any amount of precision and support bankers' rounding. Let's see an example. Big decimal BD1 is assigned big decimal dot value of, and then we put our huge fractional value here. Notice that the big decimal type has to be imported from java.math.bigdecimal, but IntelliJ will handle that for you when you select the big decimal suggestion and press Alt and Enter. Big decimal BD2 is assigned big decimal dot value of and the second fractional value. Also notice that you cannot use operators with big decimals, but instead you have to use its methods. System out println bd1 dot add bd2. Although the rounding is still not perfectly correct, it's within the industry standards, and it's significantly more accurate than floating point rounding. Although big decimal is not a primitive data type, it's very commonly used, so I decided to mention it here. We've covered all primitive types, but there is another type that technically is not a primitive type, but is often used as one. I'm talking about strings. Strings are used to represent text. String foo is assigned foo. A string is technically a data structure that represents a sequence of characters. Because strings are not primitive types, they're technically objects, and that means that strings have useful methods that we can use to manipulate them. Strings are variable size data structure, meaning it does not have a fixed size. Instead, its size is determined based on how many characters it has. The string hello world with an exclamation mark would take up 192 bits, because we have 12 characters. Since each character is 16 bits, that means 12 times 16 equals 129. One of the useful methods that strings have is the length method. System out println foo.length concatenated with foo.length. With this method, you can easily check the length of a string. We can also get a specific character from a string. System out println first character of foo concatenated with foo.character at 0. This will return the first character of the string. Note that the character indexes start at 0. We can also get the last character by using the length of foo. System out println last character of foo concatenated with foo.char at foo.length. But that didn't work. Instead, our program crashed and we got this strange message saying exception in thread main java.lang.stringIndexOutOfBounds exception. This means an exception was thrown. Exceptions are a mechanism in Java that reports errors during a program's runtime. If exceptions are not handled, they will crash the program. I will explain exceptions in one of the following lessons, but the reason this one happened is because we tried to access the character of a string at an index that's out of range. The string foo has 3 characters, but the index starts from 0, so the index of the last character would be 2. So if we try to access the character at the 3rd index, we would get an exception because it doesn't exist. To solve this, we simply decrement 1 from foo.length. Foo.length -1. We can join multiple strings together. String foo bar is assigned foo concatenated with a dash, concatenated with a bar, concatenated with a dash, concatenated with baz. The action of joining multiple strings is known as concatenation. That's why you've been hearing me say concatenate instead of plus. There are also methods that can concatenate strings for us. Foo bar is assigned foo.concat dash dot concat bar dot concat dash dot concat baz. We've formatted our method calls to look like a chain, which is more readable than just placing all our method calls in one line. You don't have to do this, but I do believe it makes the code look nicer. When checking string equality, you should always use the .equals method. Using the equals operator will not work as you expect. String foo1 is assigned foo. String foo2 is assigned foo. System out println foo1 equals foo2 concatenated with foo1 equals foo2. It prints out that they're equal, but that's actually just a happy accident that's caused by Java string optimizations. Since these two strings are identical, Java will only create one string and assign it to both variables. However, if we had a situation like this, so if I change foo2 to a string foo2, foo2.substring from 0 to 3, which is just going to return the first 3 characters, which is foo, and let's print out foo1 and foo2 before this. You would expect this to be true, right? Since it's going to compare foo to foo. Well, it prints out false, which is certainly not what we expected. That happens because strings are objects, and when you compare objects, you're actually comparing their handles, not their actual values. So to properly compare string equality, you should do this. foo1 dot equals foo2. You can also compare equality without checking case equality. System out println lowercase foo equals uppercase foo, concatenated with lowercase foo dot equals ignore case of uppercase foo. We can extract parts of strings known as substrings. String foobar is assigned foobar. We want the first 3 characters of this string. String foo is assigned foobar dot substring 0 and 3. And here we want the last 3 characters, so string bar is assigned foobar dot substring 3 and 6. The last index is not included, meaning it will extract the third, fourth, and fifth character. We can also get a substring by only specifying the starting index, so it will return everything in range of the starting index until the last index. We can check if a string starts or ends with a specific substring. System.out.println starts with foo concatenated with foobar dot starts with foo. System.out.println ends with bar concatenated with foobar ends with bar. We can split strings at certain patterns. Foobar is assigned foo.bar. String array foo and bar is assigned foobar.split, and we specify the regex of a dot. Since this is a regex, we have to escape the dot character in order to match it. System.out.println arrays dot to string foo and bar. Since the split method returns an array of strings, I've used the arrays dot to string method to properly convert the array to a string. Arrays will be explained in one of the following lessons, so don't worry about them for now. We can trim strings. Foobar is assigned some white space and then foo space bar, and followed by some trailing white space. String trimmed foobar is assigned foobar.trim. System.out.println trimmed foobar. The trim method removes leading and trailing white spaces from a string, but it does not remove white spaces between words. We can change strings into lowercase or uppercase. Foobar is assigned foo with uppercase bar. String foobar lowercase is assigned foobar dot to lowercase. String foobar uppercase is assigned foobar dot to uppercase, and I print them out. We can also search strings for characters and substrings. Foobar is assigned, this is a foobar example dot. So let's search for the A character. Int first A is assigned foobar index of character A. This will find the index of the first A character. Int last A is assigned foobar dot last index of A, and this will find the last index of the A character. System.out.println first A character index concatenated with first A. We do the same for last A. Run the program. There we go. Let's search for foo and bar in a string. Int starting foo index is assigned foobar dot index of foo. Int starting bar index is assigned foobar index of bar. System.out.println foo starts at concatenated with starting foo index. System.out.println bar starts at concatenated with starting bar index. Sometimes we don't care about the index of a substring and we just want to check if a string contains a substring. For this we can use the contains method. So I'm just going to check if the foobar string contains some words like foo, bar, and baz. There are also methods for replacing substrings. So let's say we have foobar is assigned foo.foo.bar.baz, system out print line foobar.replace foo with baz. This will replace all foo substrings with baz. System out print line foobar replace first foo with baz. This will replace only the first foo substring with baz. System out print line foobar replace all dots with a semicolon. This will replace any dot with a semicolon. Some string methods accept a regex instead of a string. Regexes are beyond the scope of this course. They are very complex and require a comprehensive course in its own right. In this lesson, we've covered the most commonly used string methods. There are many more methods that we could go through, but I feel it's unnecessary. If you want, you can do that on your own as practice. You should be able to figure out how they work based on the knowledge you've gathered so far. And if you don't understand it, try looking it up online or leaving a question on the course. When working with strings and characters, we sometimes have to represent special characters like a new line, a tab, or a Unicode character. To do that, we have to use escape sequences. To insert a new line in our string, we would write system out print line how \n r \n u \n doing. Notice how each word is inserted on a new line. Also, IntelliJ recognizes escape sequences and highlights them for you. I'm going to show you all the escape sequences in Java. System out print line foo \b. This will delete a single previously typed character. System out print line 1234 \t 123 \t 12 \t 1 \t. The \t escape sequence will insert a new tab. System out print line page 1 \f page 2 \f page 3. This escape sequence is interpreted by the printer and will move the text cursor to the start of the next page. Since our console is not a printer, we'll get this unknown character symbol. System out print line now you see me \r now you don't. This will return the cursor to the beginning of the current line, thus undoing anything before it in that line. System out print line \double quote some quote \double quote. This will insert a double quote, which is very useful when you want to use double quotes in strings. System out print line \single quote. This will insert a single quote, which is useful when declaring character variables. System out print line \\, a comment. This will insert a \, which is useful when you want to escape the \/ itself. You can also use UTF-16 characters, but you need to escape them with a Unicode escape sequence. Let's say we want to print "Hello, how are you doing?" in Swedish. We would write it like this: system out print line, and then hal \u00e5 exclamation mark her m \u00e5r do question mark. So you can use any Unicode character by simply typing \u and the hexadecimal code of that character. In Java, we have multiple ways of converting values. The base mechanism for type conversion is called casting. Casting is the process of changing how a value is interpreted. For example, Let's say we assign an integer to a long. Int a is assigned 10. Long b is assigned a. We don't have to do any explicit casting here, because the Java compiler will implicitly cast the integer into a long, since there is no danger of losing any data by casting from a smaller type into a larger capacity type. However, if we try to assign a long into an integer, that would not work. Long a is assigned 10, int b is assigned a. This code does not compile. In order to make this work, we have to cast the long value into an integer. Integer cast of a. Wrapping a type name with parentheses signifies casting. This is now valid code. Although if we had cast a long that cannot fit into an integer, the excessive bits would have been cut off and we'd get a completely different number. For example, long a is assigned 10 billion. This number certainly can't fit into an integer. System out print line b. Now that printed out a completely different number, and that's because when we casted long into an integer, the leftmost 32 bits were cut off. Let's print out the variables in binary form to see what happened. System out print line long dot to binary string, and we give it a. Another system out print line integer dot to binary string, and we give it b. So as you can see, it's going to print out a and b, and a is somewhat bigger than b. That is, it has more characters. If we align these bits, we can clearly see that 3 bits were cut off from the right side. Well, actually 32 bits were cut off, but the toBinary string method doesn't return excessive zeros on the right side. So casting from smaller to larger types is done automatically. We can cast byte into short, and short into integer, and integer into long, long into float, and float into double. While casting from larger to smaller types will require explicit casting. So we have to cast a double into a float into a long into an integer, integer into a short, and short into a byte. If you try casting strings into numbers and vice versa, you'll notice that it doesn't work. String is assigned string of 10. Int number is assigned integer cast of string. However, this doesn't work. And neither will this. Int number is assigned 10. String is assigned string cast of number. To convert strings and numbers, you need to use conversion methods. In Java, every primitive type has an equivalent reference type. For example, we have the integer class, which has useful methods for converting integers into binary or hexadecimal strings. But there is also a method for reading strings as numbers. String is assigned 10. Integer number is assigned integer.parseInt of string. This method can only parse strings that are valid numbers. If we gave it a string that was not a valid number, it would throw an exception. String is assigned 123 ABC. So the parseInt method threw a number format exception, which, as the name suggests, means that the string could not be parsed into a number. Other number classes have almost identical parse methods. To convert numbers into strings, we use a method on the string class called valueOf, which can accept any number. String.valueOf 10. You can also convert between booleans and strings. Boolean.parseBoolean of string true. string.value of true. Another common way of converting numbers and booleans to string is to use string concatenation. String 10 is assigned 10 plus an empty string. String true is assigned true plus empty string. When you add a number to a string together, Java will automatically convert the number into a string so that it can be concatenated. But keep in mind that this only works because the plus symbol gets interpreted differently because there is a string on one side. If you actually have a sequence of numbers being added before the string gets concatenated, these numbers will add up together and then the result will be converted into a string. String is assigned 10 plus 20 plus 30 plus empty string. System out print line string. Notice how that prints out 60. If we had put the string on the beginning of the expression, it would end up converting every number into a string and concatenating them together. So the order of operations here is important. We'll get more into operators and the order of operations in one of the following lessons. We've seen how to declare and assign variables and primitive data types, but usually we want to do something with them, like adding, subtracting, or comparing. We can do this with operators. So far, we have actually used a couple of operators, such as the assignment operator, which is the equal sign, addition operator, the plus sign, and the string concatenation operator, which is also the plus sign. We're going to start with arithmetic operators. As the name implies, these operators are used for operations such as adding, subtracting, multiplying, and dividing numeric values. Let's start with the addition operator. We can use the addition operator to add two numbers together and get the result. Int addition is assigned 2 plus 4, system out print line, 2 plus 4 equals, concatenated with addition. And that prints out 6. If we want to subtract numbers, we can use the subtraction operator. Int subtraction is assigned 4 minus 2, system out print line, 4 minus 2 equals, concatenated with subtraction. And that prints out 2. To multiply numbers, we use the multiplication operator. Int multiplication is assigned 4 times 4, system out print line, 4 times 4, concatenated with multiplication. And that prints out 16. And we can do division with the division operator. Int division is assigned 8 divided by 2, system out print line, 8 divided by 2 equals, concatenated with division. And that prints out 4. Note that if you divide a number by 0, that will cause an exception. Int division by 0 is assigned 8 divided by 0, system out print line, 8 divided by 0 concatenated with division by 0. And we get an exception. If you need to get a remainder of a division, you can use the modulo operator, which divides two numbers and returns the remainder of that division. Int division remainder is assigned 5 modulo 2, system out print line, 5 divided by 2 remainder equals concatenated with division remainder. And we get back 1. Modulo is useful when we want to check if a number is odd or even. If we modulo anything with 2 and there is a remainder, that means it's an odd number. Otherwise, if there is no remainder, that's an even number. There are also combined versions of arithmetic and assignment operators, which are handy for doing arithmetic operations with assignment. For example, int x is assigned 50, int y is assigned 20, x plus equals y, system out println x. Without this operator, our expression would look like this. X is assigned x plus y. So it saves us a bit of effort. All arithmetic operators have a combined assignment form, so you can do subtraction, multiplication, division, and modulo with assignment. All of these will do the arithmetic operation first and then assign the result to x. Lastly, for arithmetic operators, we have unary arithmetic operators, which are useful shorthands for incrementing and decrementing variables, and they're commonly used in loops. For example, here we have the unary increment operator. Int u is assigned 5, system out println u++, system out println u, system out println ++ u. So if I run this, we can see first it prints out 5, then it prints out 6, and then it prints out 7. Notice how this operator has two different variants. The first one has the operator on the right-hand side of the variable. What it does is it increments the variable by 1 and then returns the old value of the variable. While the second variant, where the operator is on the left-hand side, will increment the variable and immediately return the new incremented value. We also have the unary decrement operator, system out println u minus minus, system out println u, and system out println minus minus u. And first it prints out 7, then 6, and then 5. Arithmetic operators allow us to do basic arithmetic operations like adding, subtracting, multiplying, and dividing numbers. However, we will often find ourselves needing to do more advanced operations like rounding numbers, getting an absolute value, getting a min or max value, square roots, power of n's, logarithms, and so on. In Java, there is a built-in class that contains methods exactly for these cases, and it is the java.lang.math class, which provides us with a plethora of static methods for advanced arithmetic operations. Let's say we have two numbers like this. Double A is assigned negative 24.20. Double B is assigned 31.59. We can get an absolute value of this number. System out printf, absolute value of %f equals %f%n, and then I pass the arguments a and math.abs of a, and that prints out positive 24.20 because math.abs provides us with an absolute value of something. We can round, floor, or seal numbers. System out printf, rounded value of %f is equal to %d%n, and we pass the arguments b and math.round of b. This will round the number to the nearest long value. System out printf, floored value of %f is equal to %f%n, and we pass the arguments b math.floor b. This will round the number to the largest value that is less than or equal to it. System out printf, sealed value of %f is equal to %f%n, and we pass the arguments of b and math.seal of b. This will round the number to the largest value that is greater than or equal to it. We can get a minimum or maximum of two values. System out printf min value of set %f and %f equals %f %n, and we pass it the arguments a, b, and math.min of a and b. And we do the same for the max value, but we just say math max of a and b. We can get commonly used constants like the Euler's number and pi. System out printf Euler's number equals to %f %n, and we pass it the argument of math.e. System out printf pi number equals %f %n, and we say math.pi. We can get exponents, logarithms, square roots, and raised to power. System out printf exponent of %f equals to %f %n, and we pass it arguments of b and math.exp of b. This will return the Euler's number raised to the power of a number. System out printf logarithm of %f equals to %f %n, and we pass it the arguments of b and math.log of b. This will return the natural logarithm of a number. System out printf square root of %f equals %f %n, and we pass it the arguments b and math.square root of b. This will return the positive square root of a number. System out printf %f to the power of %f equals %f %n, and we pass it the arguments of b, 2, and math.pow, and we pass it b and 2. This will take the first number and raise it to the power of the second number. In this case, it will take b and raise it to the power of 2. We can convert angles from degrees to radians and vice versa. System out printf %f radians equals %f %n. We pass it the arguments of b and math.2 radians of b, and we do the same for degrees, but we just say math.2 degrees of b. We also have some basic trigonometric methods. System out printf sine of %f equals %f %n, with the arguments of b and math.sine of b. We do the same for cosine, but instead we say math.cos, and we pass it b. And we do the same for tangent, but we just say math.tan of b. Note that these trigonometric methods expect the argument to be in radians, not degrees. So if you are working with degrees, make sure you convert them into radians before using the trigonometric functions. We can also generate random numbers. System out printf random number between 0 and 1.0 equals %f, and we pass it the argument of math.random. This returns a random double value between 0.0 inclusive and 1.0 exclusive. We can multiply and round this random value to get a whole number. Long random is assigned math.round, and we pass it the argument of math.random times 100. System out printf random number between 0 and 100 equals %d, and we pass it the argument of random. This will generate a random value between 0 and 100. When we have complex expressions with many arithmetic operations, we have to consider the order of these operations. Luckily, in Java, operator precedence follows the same rules as in math. Parentheses are evaluated first, then division, multiplication, subtraction, and addition. For example, int precedence result is assigned 4 minus 2 plus open parentheses 10 plus 5 close parentheses plus 5 times 10 divided by 2. System out print line precedence result. So the correct mathematical result for this expression would be 42. And as we can see, we get 42 as the result. Had the program not followed the correct order of operations, we would have gotten a different number. Now, this doesn't mean you cannot change the order of operations at which the expressions are evaluated. We can use parentheses to force a part of an expression to be evaluated earlier. For example, int result is assigned, open parentheses, 10 plus 5, close parentheses, times 10. System out print line result. So we get 150 as the result, but if we had not used parentheses, the result would have been 60. So whatever is in the parentheses will be evaluated first. Now, I've only explained the operator precedence for numbers, but we know that we can add strings with numbers and the Java compiler will automatically parse the number into a string so that it can be concatenated. Well, the concatenation operator has the same precedence as addition, so this can lead to some interesting cases. For example, string result is assigned empty string plus open parentheses 10 plus 5 closed parentheses times 10. System out print line result. So this will first evaluate the addition and multiplication operations and then concatenate the string. But what if we had a case like this? Well, here it will first evaluate the parentheses, then it will concatenate the result to the string and carry on to concatenate with 20 and 5. That's why it ends up printing 205 at the end. If we actually wanted to add 20 with 5 and then concatenate the result with the string, we should have just used the parentheses, like this. I've explained the precedence of arithmetic operators. However, there are many more operators in Java, and you don't really have to know in which order they're executed. We could go on all day talking about possible operator precedence scenarios. Instead, I will leave you with this table that shows you the precedence of each operator in Java, should you ever need to consult it. Logical operators are used for checking value equality and relations between values. These operators are most commonly used with conditional statements and loops. So let's say we have two variables. Int x is assigned 1 and int y is assigned 2. We can check if they're equal by using the equality operator. System out print line, x is equal to y, concatenated with, and then in parentheses we say x double equals y. And then we print out x is equal to 1, concatenated with, and once again in parentheses x double equals 1. So the first one prints out false and the second one prints out true. We have to surround the equality check with parentheses, otherwise Java will think we're trying to compare a string with a number, which is not possible, since they are different data types. For some types, Java will do automatic conversion, like when we're comparing floats with integers. It will implicitly convert the integer to a float and then do the comparison. But you shouldn't rely on this. Always make sure you're comparing values of the same data type, otherwise make sure to explicitly convert the types. We can also check for inequality. System out print line, x is not equal to y, concatenated with x not equal to y, and we also print out x is not equal to 1, concatenated with x not equal to 1, prints out true and then false. We can check if one value is greater than the other, x is greater than y, concatenated with x greater than y, and we also print out y is greater than x, concatenated with y greater than x. So here, first one prints out false, then the second one prints out true. We can check if a value is less than the other value. X is less than y, concatenated with x less than y. And we also print out y is less than x, concatenated with y less than x. So it prints out true and then false. Conveniently, we can check if a value is greater than or equal to another value. System out print line x is greater than or equal to y, concatenated with x is greater than or equal to y. We also print out x is greater than or equal to 1, and we also print out x is greater than or equal to 0. So this prints out false, true, and true. We can also check if a value is less than or equal to another value. X is less than or equal to y, and we print out x is less than or equal to 1, and we also print out x less than or equal to 0. When we want to check multiple conditions, we can use conditional operators. Let's say we want to check if a number is within a certain range. For this, we could use the logical AND operator like this. Int number is assigned 30. System out print line, number greater than 20, and then we write two ampersand symbols together, which represents the AND operator, number less than 40. So we checked if the value of the variable number is between 20 and 40, and indeed it is. Notice that for this condition to be true, both sides of the logical AND statement have to be truthy. If either one of them evaluates to false, the entire statement evaluates to false. By the way, the term truthy refers to an expression which evaluates to true. Conversely, we could say falsy for expressions which evaluate to false. Let's say we want to check if a number is not within a certain range. For this, we can use the conditional OR operator like this. System out print line, number greater than 20, and we say double straight lines, which represent the OR operator, and then we say number less than negative 20. Unlike the AND operator, the OR operator will evaluate to true if at least one side is truthy. Our number is certainly not less than negative 20, but it is greater than 20, which causes this conditional OR statement to evaluate to true. There is another conditional operator which is very commonly used, especially when assigning values. Let's say we want to check a condition and then get a value depending on the result. So for this we can use the ternary operator. String result is assigned number greater than 35, question mark. If true, we will return is greater than 35, double colon, which means otherwise we will return is less than 35. System out print line result. The ternary operator is a bit special because unlike the other operators, it's divided into three individual parts. The evaluation expression, the value to return if the expression evaluates to true, and the value to return if the expression evaluates to false. It might be a bit difficult to wrap your head around this operator, but don't worry about it. It will probably make more sense once I explain the if statements. So far, we've worked with variables that hold a single value, but sometimes we need to represent many values together. Maybe we want to bundle a sequence of numbers or strings into a single variable. We can do that with arrays. Arrays are basically container objects that hold a fixed number of elements of a single type. We could have an array of integers, strings, characters, etc., but we can never have an array of mixed types. Let's create an array of numbers. First, we have to declare a variable of type integer array. Int array numbers is assigned new integer array of 5 elements. Array data types are a bit special. They have two parts. The first part is the data type of elements that will be stored in the array. And the second part is a pair of brackets. On the left side, these brackets simply indicate that this is an array data type, while on the right side, where we're doing assignment, we need to use the new keyword and place a number inside the brackets representing the number of elements this array holds. It's also possible to declare array types in a C style like this. But this is not recommended and it goes against the Java coding style. You will be hard-pressed to find anyone declaring arrays like this in Java. Even IntelliJ is warning us about using C-style array declaration. Now that we've declared an array that holds 5 elements, we can assign values to it. Numbers at index 0 is assigned 8. And we assign the rest of the indexes. Notice how, when we're assigning values to an array, we have to tell it at which index we're assigning the value. So an array is split into multiple parts referred to as elements. In our case, we have 5 elements, and each element is accessed by specifying an index between the brackets. Pay attention that the index starts counting from 0. So the first element inside the array has the index 0, while the last one has the index 4. Regarding this array example, you can imagine as if we declared 5 variables and assigned each one of them individually. Reading elements from an array is also done by specifying the array index we want to read from, like this. Systemout.println, first element, concatenated with numbers at index 0. Systemout.println, last element, concatenated with numbers at index 4. You can also declare arrays using a shorter syntax, new int array, and we open curly braces and we simply define elements we want inside the array. This is very useful when you know ahead of time what elements you want to have inside the array. The compiler is smart enough to determine the size of the array for you. You can actually omit the new int array part because the Java compiler can infer the type of the array from the variable type declaration. But you can only do this when declaring the array. Unfortunately, if you're assigning a variable after declaration, you have to explicitly specify the array type. So then we have to say new int array. When naming array variables, prefer to use plural nouns. Notice how I named the array that contains numbers. I literally named it numbers, and this makes sense. It's confusing to name your array variables as singular nouns. So you always make sure that your array variable names imply multiples of something. For example, you wouldn't name an array number. Instead, you would name it numbers or number array. You don't have to do it like this, but you should always make sure that your variable names accurately reflect their type, value, and meaning. You can also declare an array of arrays, aka multidimensional arrays. This effectively means that you have an array whose individual elements contain an array. Although this might seem complicated, it's not so bad. It's just a matter of perspective. Multidimensional arrays are generally used when dealing with matrix multiplications or creating data structures, so it's unlikely that you will have to use them unless you're building data structures yourself. However, they are still a foundational part of Java, so I will explain them. Let's see an example of a two-dimensional array. Int array array number table is assigned new int array, where the first dimension contains 2 elements and the second dimension contains 2 elements. So here we've declared a two-dimensional integer array. The way you add elements to a multidimensional array is very similar to how you would add them to a normal array, except that you have to specify 2 indexes. Number table at index 0 of the first dimension and index 0 of the second dimension is assigned 8, and so on. It seems a bit confusing, but here's what's going on. We're first selecting the parent array index, then we're selecting the child array index. So basically, we have to do the index selection twice, because Java needs to know in what index of the child array do we want to write the value. You can visualize it as a table where the first dimension represents rows and the second dimension represents columns. So every time you're accessing the array, you need to specify the row and column indexes. It's like specifying coordinates of the element you want to access. To read an element from the array, you simply specify the indexes. System out print line, row 0 dash column 0, concatenated with number table at index 0 of the first dimension and index 0 of the second dimension, and just do the same for the rest of them. You can also initialize multidimensional arrays with the shorthand syntax like this. Number table is assigned, and we open a pair of curly braces, and then between these curly braces we open up another pair. We give it 8 and 16, dash, and then we add another pair of curly braces, and we give it 32 and 64. In multidimensional arrays, each initializer block specifies a dimension. Since this is a two-dimensional array, we have 2 levels of nesting. The first one represents the parent array, and the second one represents children arrays, which contain values. With the shorthand syntax, it's possible to have child arrays of different lengths, because they are separate arrays anyway. They don't have to have the same size as their parent array. So we just add more numbers to the first pair of the curly braces, 32 and 64, and the second pair we'll say is 128 and 256. So the first child array has 4 elements, while the second child array has 2. Because of this, you may hear people say that Java technically does not have multidimensional arrays, but instead it simply has arrays inside arrays. Although this is technically true, it doesn't really matter because you are highly unlikely to ever create arrays inside arrays that have different lengths, even if it is possible. To really reinforce the concept of multidimensional arrays, let's make a 3-dimensional array to see what that looks like. So we say int array 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 3D is assigned new int array, where the first dimension contains 2 elements, the second one contains 2, and the third one also contains 2. And then I'm just going to go through all the elements and assign them some values. So as you can see, the amount of values that this array can hold is significantly greater than the 2-dimensional array. Usually we don't work with multidimensional arrays manually, and instead we use loops, but we'll get to those later. To make it easier to visualize these multidimensional arrays, you can imagine that each dimension represents something. In this case, the third dimension represents pages, the second dimension represents rows, and the first dimension represents columns. Let's print out the elements. System out print line, page 0 dash row 0 dash column 0, concatenated with array 3D at index 0 of the first dimension, index 0 of the second one, and index 0 of the third one. and we do the same for the rest of the elements. As you can see, it's much easier to understand what you're writing when you visualize it. Finally, to really consolidate multidimensional arrays, let's see what a 4-dimensional array would look like. Int array 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 4D is assigned new int array, where the first dimension contains 2 elements, the second one also contains 2, the third one also contains 2, and the fourth one also contains 2. And then we say array 4D at index 0 of the first dimension, index 0 of the second, third, and fourth, and we assign 1. And we assign values to the rest of the elements. Now that's huge. Here we can imagine the fourth dimension represents books, the third dimension represents sheets, the second dimension represents rows, and the first dimension represents columns. So as I've said, multidimensional arrays are not so bad when you can visualize them. Lastly, let's print all the elements out. System out print line, book 0, dash page 0, dash row 0, dash column 0, concatenated with array 4D, at index 0 of the first dimension, index 0 of the second one, the third one, and the fourth one. And just copy paste the rest of them. Nice. We've seen how we can declare, read, and write to and from arrays. However, there is much more we can do with arrays, like searching, comparing, copying them, and so on. One of the basic properties all arrays have is the length, which represents the total number of elements the array can hold. The length of an array is immutable, meaning it cannot change after it's been created. Let's see an example. String array foo is assigned, open a pair of curly braces, foo dash bar dash baz. System out print line, length of foo concatenated with foo dot length. We can also use the length property to access the last element of the array. System out print line, last element of foo concatenated with foo at the index of foo dot length. Oops, I actually made a mistake here. Can you spot it? The array indices start from 0, so the last index of this array would be 2, not 3. So I have to subtract 1 from foo.length. There we go. The length property is also necessary when processing arrays in loops, because we need a way of telling the loop when to stop. I will explain loops in one of the following lessons. Just as we can check the length of a one-dimensional array, we can also check the length of multidimensional arrays. To be more precise, we can check the length of the nested arrays. There isn't actually a property that sums the length of all the nested arrays. You would have to do that yourself. Here is an example. Int array array, array2d is assigned new integer array with 2 elements at the first dimension and 4 elements at the second dimension. System out print line, parent array length, concatenated with array2d length. Now this will just give us the length of the first dimension, which is going to be 2 because we only have 2 child arrays in the main array. System out print line, first child array length, concatenated with array2d at index 0 dot length, and system out print line, second child array length, concatenated with array2d at the first index dot length. So these will print out the child array lengths, which is going to be 4, and then system out print line, total element capacity, concatenated with array2d at index 0 dot length plus array2d at index 1 dot length. And this will print out the combined length of all the nested arrays. Now, something you need to understand about arrays is that they're not a primitive type. They are a reference type. which means arrays cannot be copied with reassignment. So this would not work. Int array, array1 is assigned an array of 1, 2, 3. Int array, array2 is assigned array1. This will actually not copy the first array, but instead it will copy the handle of that array. Once again, this is because arrays are not primitive types, they're reference types. Let me show you what I mean. Let's change an element inside the first array, after we assigned it into the variable. Array1 at index 0 is assigned 32. And let's check if they're equal. System out print line, arrays are equal, concatenated with, and then we check array1 equals array2. And it prints out true, and that's because it's still the same array, but its handle has been assigned into two different variables. This is because of how Java passes object values and primitive values. When comparing equality of arrays or objects, we're not comparing the values inside them, but instead we're comparing their handles. I'm not going to go into depth on this right now because I have an entire lesson dedicated to this in the second part of the course, Java OOP. But basically what's happening is when we declare an array, Java is going to create that array in memory and give us a handle to that array. And through that handle, we can manipulate that array. So when we assign an array to a variable, we're really just assigning a handle to that array, not the actual array. The same logic applies to objects. So how do we actually copy an array then? Well, we can use the Arrays utility class, which contains convenience methods for array manipulation, and it has a method for copying arrays. Array2 is assigned arrays.copy of array1-array1.length. Now we need to import the arrays class. In IntelliJ, you can hover over the arrays class name and wait for a prompt. Now press Alt and Enter, and IntelliJ will import the class for you. Alternatively, you could type in the full package name like this, java.util.arrays, but this is unnecessarily verbose, so always prefer importing packages over defining fully qualified package names. So if we check the array quality now, it prints out false. And that's not because we've changed one of the elements of the first array. If I remove that part, it will still print out false, and that's because the array handles are different now. Let's print out the contents of the copied array. System.out.println array2. Okay, that's definitely not what our array looks like. So what's happening here? Well, it's similar to what happened to when we try to copy the array by reassigning it. Here we're printing out the handle of the array, not the array itself. So the Java compiler will implicitly add a .toString method call on our array, and that will generate this hash-like string. We can actually see what this method looks like. I'm going to press Ctrl and left-click on the toString method, which will open the definition of this method. So this method takes the object class name, appends the @ and the hash code of the object handle. If you're wondering why this method is located in object.java and not intarray.java or something like that, that's because all reference types in Java inherit the object class. Don't worry about this for now, I will explain classes, objects, and inheritance in the second part of the course. Just understand that whenever you try to print out an array or an object, you will get this hash-like string. To print out the array contents, you can use another method from the arrays class, which nicely generates a string representation of an array. Arrays.toString, and we give it array2. And there is our array. If you need to print out multidimensional arrays, make sure to use arrays.deepToString. Let's say we have a 4-dimensional array. If we use arrays.toString to print it out, it won't work as you expect. So it's not working right. Instead, there is a special method for generating strings from multidimensional arrays. Arrays.deep2string array4d. And that works beautifully. We can also selectively copy a portion of the array by using arrays.copyOfRange, like this. Arrays.copyOfRange, and we give it array1, and then we need to give it the starting index inclusive, so I'll just say 1. And then we need to give it the ending index exclusive, array1.length. And that copies the elements from the first index inclusive until the last index exclusive. Next, let's take a look at sorting. Say we have a number array like this. Int array, numbers is assigned, and we have a bunch of unsorted numbers. System out println arrays.toString numbers. Now, if we wanted to sort the numbers in the array from smallest to largest, we could use arrays.sort. Arrays.sort numbers. And our numbers got sorted. We can also sort strings. String array words is assigned, and I'm going to pass it some strings. Arrays.sort of words. System out println arrays.toString words. Very nice. Unfortunately, to reverse sort arrays of primitive types, you would have to write your own method for that. Because for some reason, the arrays class does not have a reverse sort method. There is a sort method that accepts a comparator object for its second parameter, but that doesn't work on primitive types. We can search an array by using arrays.binarySearch like this. Int index is assigned arrays.binarySearch, and we pass it numbers and what we're searching for. I'm going to ask for number 16. System out println found the number 16 at index, concatenated with index, and let's print out the number itself. So arrays.binarySearch will return the index of the element we're looking for. However, if it doesn't find it, it will return a negative number. Let's try searching for an element we certainly don't have in our numbers array. System out println arrays.binarySearch on numbers, and we're searching for 0. And it prints out a negative number because it cannot find number 0 in the array. We can also selectively search a portion of an array. Arrays.binarySearch. We're searching numbers, and I wanted to start at index 4 inclusive and search up until numbers.length, which is exclusive, and we're looking for number 16. There we go. We can search for mismatches between two arrays. Int array numbers2 is assigned, and we have an array of numbers similar to the last one, but not exactly in the same order. Int mismatch index is assigned arrays.mismatch numbers dash numbers2. System out println mismatch at index concatenated with mismatch index. So there is a mismatch at index 2. We can also specify a range for the mismatch search. Arrays.mismatch. We give it numbers, and then I want it to start on the 4th index inclusive and go up to numbers.length exclusive. And we're comparing it to numbers2, also starting at index 4 inclusive and going up to numbers2.length exclusive. And this will return the relative index of the first mismatch. So since the search starts at index 4 inclusive, that means 4 plus 2, which is index 6. And let's print out what is at index 6 of both arrays. And as we can see, indeed, these two are different. To check array equality, we can use the equals operator, but that will only check if the array handles are equal. It won't actually check the equality of the array's contents. So let's say I have character array, letters 1 is assigned A, B, C, D, and we have character array, letters 2 is assigned letters 1. System out print line, are array handles equal, concatenated with, letters 1 equals letters 2. And they are indeed equal, because it's the same array handle just assigned to two different variables. But if I initialize the second array with the same contents like this, their handles are no longer equal because the second variable was given a new array instance. To check element level equality, we can use the arrays.equals method. System out print line, are array contents equal, concatenated with, arrays.equals, letters 1 and letters 2. And it prints out true, because this method compares the array contents, so if I added one element to the second array, they won't be equal anymore. If you want to check the equality of multidimensional arrays, you have to use the arrays.deepEquals method. For example, let's say I have two two-dimensional arrays with the same contents, but they are different instances. System out print line, arrays.deepEquals mdarray1 and mdarray2, and it prints out true. And if you change one of the elements in one of the arrays, they will no longer be equal. Lastly, I will explain one more method. We can use arrays.fill to fill an entire array with a value. Int array, 0 array, is assigned new int array of 20 elements, arrays.fill 0 array with the value 0. System out print line, arrays.toString 0 array, and the entire array is filled with zeros. Well, that's just about all the array manipulation methods. Although there are more of them, they are used in some advanced cases, so I won't explain those as it's unlikely you will ever use them. So far, we've written small programs that always execute the same path of code, but in real-world applications, developers use conditional statements to control the flow of the program. This means that we can conditionally execute code based on the conditions we specify, which allows us to write much more useful programs. In Java, there are a few mechanisms that allow us to control the flow of the program. First is the if statement. The if statement is the most basic of control flow statements, and you will be using it extensively in your code. It allows you to execute code depending on a result of an expression. Let's say we want to create a small program that checks if we have enough money in our wallet to buy some items. Int wallet is assigned 800. This is going to represent our balance. Int array item prices is assigned, and we pass it some numbers. These are the items we can purchase. Int total is assigned item prices at index 0 plus item prices at index 3. Let's say we're buying the first and the last item. Now we need to check if the total exceeds our wallet balance. If total greater than wallet, we print out that's too expensive. Otherwise, we print out the total purchase. Else, system out print line, nice purchase, /t, which is the tab character, dash, concatenated with total, concatenated with the string credits. That prints out nice purchase with the amount we've spent. If I reduce the wallet balance below the total purchase amount, we're going to get a different message. Let's say we have like $200 inside our wallet right now. Run the program. Nice. So we can conditionally print out different messages depending on the total price of the purchase and the wallet balance. We can expand this to check for more conditions if we want. Let's say we want to print out a message for when the total is 0 and when the total purchase amount equals the wallet balance. We would say else if total equals 0. In that case, print out you didn't purchase anything. Else if total equals wallet. And in that case, we print out wow, your wallet balance matches the total amount. Now let's try it out. I'm going to set the total amount to 0. Nice. And let's set the wallet balance to 0 as well. It still prints out the same message. So what's going on here? Well, you can chain as many else-if statements as you want, but only one will get executed. In this case, because the total amount was 0, the expression which checks that got executed first. So the program exits the if-else chain and continues from there. If we want to execute code for multiple conditions, then we shouldn't use else-if statements. Instead, we should use only if statements, like this. However, this leaves us with a small issue. How are we going to execute our else statement? Well, we can simply check the opposite condition of the first if statement. If total less than wallet. And now if I run the program, both if statements get executed. I didn't show you this before, but you can actually read input from the console. This is important for building interactive programs where the input data can be provided by the user. We can use if statements to conditionally execute code based on the user input. For example, we could ask the user to type in their age, and based on their input, we would print out a message. Let's see an example. First, we need to create a scanner object. Scanner is assigned new scanner, and we pass it system.in. The scanner class provides capabilities for reading the console input. The new keyword is used to create an object instance of the scanner class. I haven't explained classes and objects yet, and I'm going to cover that topic in the second part of this course called Java OOP. When we created the scanner object, we passed it system.in as an argument. System.in just represents the console input stream, and it's required in order to read the data from the console. Let's ask the user for their age. System.out.print. Enter your age. We're not using the print line method because it adds a new line at the end of the string. But we don't want that because we want the input to be in the same line as the question. Int age is assigned integer.parseInt, and we say scanner.nextLine. Calling the scanner.nextLine method will return one line of input from the console as a string, so we need to convert it into an integer using integer.parseInt. Note that if integer.parseInt receives a string that cannot be converted to a number, it will throw an exception and crash our program. We could handle this case by using a try-catch block, but it's too early to explain that, and I will cover exceptions later in the course. If you want to, you can do that as an exercise. Anyway, let's continue. Now we need to check what number was entered, and based on that, we need to print a specific message. For example, we want to print different messages. One for when the user is older than 18, or is between 14 and 18, is between 4 and 14, is between 1 and 4, and is less than 1. So each one of these cases should print out a different message. I encourage you to pause the video and try doing this yourself. Alright, I hope you gave it a shot. Let's see the solution. If age greater than 18, we print out you are an adult. Else if age greater than 14 and age less than 18, we print out you are a teenager. Else if age greater than 4 and age less than 14, we print out you are a child. Else if age is greater than 1 and age is less than 4, we print out you are a toddler. Else, we print out you are a baby. Now let's run the program and try some numbers. Nice! It works like a charm. We could make this code look a bit cleaner by omitting the brackets and just specifying the print statements. It looks cleaner, but you can only have one line of code below the if statement if you're not using the braces. I would say that most Java developers prefer to use braces with if statements because it helps clarify if statement boundaries. It can also make the code inconsistent if you're mixing if statements with and without braces. Another mechanism for control flow in Java is the switch statement. The switch statement allows us to conditionally execute code depending on a variable value. It's similar to the if statement, but unlike the if statement, it cannot directly check expression results, and it can only be used on variables with several data types like integers, characters, strings, and enums. Thereby, switch statements are generally used in places where you need to check ranges of values, while if statements are used for checking expression results. To demonstrate the switch conditional statement, we're going to write a small program that accepts a month number as an input, and we will use the switch statement to display the proper month for that number. First, let's create a scanner object. Scanner is assigned new scanner, and we pass it system.in. Let's ask the user to enter the month number. System.out.print enter month number, and parse it into an integer. Int month number is assigned integer.parseInt, and we say scanner.nextLine, which will return a single line of input. Okay, so we got our input solved. Now we're going to define the switch. First, let's declare a variable that will hold the month name. String month name is assigned null, and we define the switch statement. We're giving it month number because that's the variable we want to evaluate. Switch month number, and we open a block with braces, and then we say case 1 double colon, and then we write what we want to do in the case if the value is 1. In this case, we want to assign the month name as January. Break. So here we have a switch statement which is given a variable, and then we define cases. Each case is like an if statement. It checks if the switch value is equal to the case value. The break statement is used to exit the switch block. Without placing the break statement, the switch would fall through into the next case statement, and it would keep falling through until it hits a break statement or a default statement. Now let's add the remaining cases. As the default case, we will assign a month name of unknown month, and then we print out month name concatenated with the variable month name. The default statement is only executed if none of the case statements broke out of the switch block. You can also define blocks for the case statements or the default statements, like this. But they are kind of redundant because the indentation already clarifies what code gets executed in which statement, and you're not limited to one line unlike the if statement. Now, I mentioned that break statements are used to exit the switch statement. If we didn't use them, all the case statements would get executed. So let's remove the break statements and see what happens. As we can see, it prints out unknown month, and that's because it fell through all the case statements and finally executed the default statement. To visualize what's happening here, let's add print line statements for each case. So I'm going to select case and press Shift Ctrl Alt and J, which will select all occurrences of the text case. I'm going to press arrow down, press End, and press left arrow twice to get inside the string quotations. Hold Ctrl and Shift, then press arrow left. Then Ctrl C to copy text. Now we press End again to take us to the end of the line. Press Enter to add a new line. Type systemout.println. Then press Ctrl and V to paste. Press N to close the print line statements. And we're done. I wanted to show you how easily you can do mass edits with IntelliJ, but you don't have to do it like this. It might be too much to remember for your first time, but don't worry, it will come to you naturally as you practice. So if we run the program again, we can see how all the cases are executed. With this in mind, we could write our switch statements to execute the same code for multiple cases, like this. So this will print out all the months of the quarter year in which the selected month belongs. As I mentioned earlier, with switch statements, you can only check variable values and nothing else. So if you tried this, case month number greater than 8 and month number less than 12, this wouldn't work. Also, we're limited to several data types as well, so if I change the month number to the type float, float month number, that wouldn't work. As you can see, we're getting a compilation error, which is saying that switch statements only work with integers, characters, strings, and enums. So as you can see, switch statements are pretty limited to what sort of conditions they can be applied in. So if you need to check any more complex conditions, you should definitely be using the if statements. Loops are the foundations of any program, and they are used to repeat a set of actions until a given condition fails. Every loop includes a test condition and a code block to be executed if the test condition evaluates to true. Each individual cycle of the loop is called an iteration. The most basic of all loops is the while loop. As mentioned earlier, the while loop has a test condition and statements which are executed each iteration. Let's consider the following scenario. Say we have a queue of messages we need to process. We would have to iterate over each message and process it. We could do this manually by writing repetitive code for processing each message, but that would be very unwise and prone to errors. However, with the while loop, we can write the logic for processing a message once and apply it to all messages. Let me show you. Int num of messages is assigned 5. We are going to pretend we have 5 messages to process. While, open parentheses, num of messages greater than 0, close parentheses. And then we open up curly braces. Here, we write the logic we want to execute for each message. In this case, I simply want to print out processing message concatenated with num of messages. Then we have to decrement the remaining number of messages, otherwise this would be an infinite loop. And once we're done, we simply print out no more messages, terminating program. Run the program. Nice. Let's go through this step by step. So we have a variable, num of messages, which serves as a counter for how many messages we need to process. That is, how many iterations the loop has to execute. Next, we have the test condition, num of messages greater than 0, which is evaluated before each iteration, and if it evaluates to true, the iteration will execute. Otherwise, the program exits the loop. Inside the loop block, we have the code we want to execute in each iteration, so we print out a message and decrement our counter variable. Once the counter variable is 0, the program exits the loop and proceeds to execute the print statement. It can be difficult to wrap your head around loops for the first time, but you'll get used to them after a while. Be persistent and don't give up. Next, we have the do-while loop, which is very similar to the while loop except for one major difference. The do-while loop will first execute the iteration and then test the condition for the next iteration, versus the normal while loop logic where the condition is first tested before executing the iteration. Let's take the previous example of processing fictional messages, but with the do-while loop. Int num of messages is assigned 5. Do, and we open a block of curly braces. So here we first execute an iteration. System out print line, processing message concatenated with num of messages. And we decrement the num of messages. Then we test the condition, while num of messages greater than 0. Once done, we simply print no more messages, terminating program. Run the program. There we go. As I've said, compared to the while loop, the do-while loop first executes the iteration and then it evaluates the test condition. That means if we set the num of messages to 0, it would execute one iteration of the loop and then evaluate the test condition for the next iteration, which will be false and it will exit the loop. So I'll set the num of messages to 0, run the program, and the first iteration still got executed. To recap, the do-while loop first executes the statements inside the block and then it evaluates if the test condition passes. And if it does pass, it executes the next iteration of the loop. While the while loop first evaluates the test condition and then if the condition passes, it executes the statements inside the block. To be honest, the do-while loop is not very widely used, and developers prefer using the while loop or even commonly the for loop, which I will explain next. The most popular loop type in all of programming languages is the for loop. The reason behind the for loop popularity is quite simple. It groups all the loop components in its signature, which makes it practical to use, and you can tell at a glance what the test condition for the loop is. Let's take the already seen example of processing fictional messages and write it using the for loop. So we declare num of messages again and assign it the number 5. Then we say for, open parentheses, int I is assigned 0, semicolon. So this is the counter variable. Then we say I less than num of messages. That's the test condition. And lastly, we say I++, and that's the increment expression. And then we close the parentheses and open a curly block. And here we put the logic that's executed in each iteration. System out print line, processing message, concatenated with I. And just to clarify, we could have completely removed the num of messages variable and said I less than 5 for the test condition. But here we're pretending that the num of messages was received as a parameter. Let's run the program. Very nice. Let's go over this step by step. The for loop contains 3 expressions inside the parentheses: the initialization expression, the termination expression, and the increment expression. The initialization expression initializes the counter variable. The termination expression is the test condition which is evaluated in every iteration. And the increment expression is how we want to change our initialized variable every iteration. Notice that this time we've processed the messages from bottom to top because we started incrementing from 0 to 5. If we want to process the messages from top to bottom, then we have to reverse the loop evaluation logic. In this case, we would say for int I is assigned num of messages, or just 5, and then I greater than 0, I minus minus. Run the program. And now we've processed the messages from top to bottom, because the inner int I variable was given the value of num of messages, and we've changed the test condition to check if I is greater than 0, and we're decrementing it in each iteration. An interesting feature of the for loop is that you can actually omit expressions in the parentheses. For example, I could omit the counter variable declaration. So I would just say for and immediately place a semicolon and then just proceed to write the test condition and the increment or decrement expression. And now we would just print out processing message concatenated with num of messages. And this would still work. Run the program. It works. We could also omit the decrement expression and place it inside the loop body. So we would just say for semicolon num of messages greater than 0 semicolon. And we would just say inside the loop body processing messages concatenated with number of messages minus minus. So this would just return the value of num of messages and then it would decrement it. Or we could make an infinite loop by omitting all expressions. For semicolon semicolon, and we would just say processing messages concatenated with num of messages minus minus. But this would be an infinite loop, it would keep running forever. Speaking of infinite loops, I haven't mentioned them before. Infinite loops are loops whose test condition never evaluates to false, meaning they will run forever. In Java, you will most likely never have a need to create an infinite loop, and if you do create one, it's guaranteed to be an unintentional bug. Even if you have a scenario where you need to run a loop continuously, like maybe if you're making a program and you need to render frames for as long as the game is running, make sure that your loop checks a Boolean variable of some kind, like is game running. So at least you have a way of terminating a loop by setting that variable to false. In terms of popularity, the for loop is by far the most popular, followed by the while loop, and followed by the do-while loop, which almost no one uses. As you've noticed, loops have test conditions, also known as termination conditions. However, sometimes we need to exit the loop earlier or skip iterations. To achieve this, there are two special statements that we can use. First, there is the break statement, which you may remember from switches. However, when used inside a loop, it causes the program to exit the loop. Let's say we have a loop and we want it to stop once we hit a lucky number or once we get to 100 iteration. The lucky number is randomly generated, so every run of the program will be different. First, we declare a counter variable which starts at 0. Int counter is assigned 0. The lucky number will be pseudo-randomly generated using the math.random method multiplied by 100, which means the maximum generated value will not exceed 100. Long lucky number is assigned math.round, and we pass it math.random times 100. Now let's declare a while loop that executes no more than 100 iterations. While counter less than 100, open curly block. Now we check if the counter value matches the lucky number. If counter equals lucky number, open another curly block. If it does, we break out of the loop. Otherwise, we increment the counter. And at the end, we print out the lucky number, finished at number and concatenated with counter. Run the program. As we can see, the loop terminated as soon as it reached the lucky number, and if we run it multiple times, we get multiple lucky numbers. So this is how you can use the break statement to specify additional termination conditions inside the loop body. If we want to skip an iteration of the loop without terminating it, we can use the continue statement. Let's change our previous example up a little so that it prints out every number except for the lucky number. I'm going to reduce the counter limit to 10 so that we can more easily read the output. Int counter is assigned 0. We now want a lucky number between 0 and 10. While counter less than 10, we check if the counter value equals the lucky number. If counter equals lucky number, if so, we want to increment the counter and continue to the next iteration, counter plus plus, and we say continue, which will skip the current iteration. Otherwise, we print the counter value and increment the counter. Run the program. As we can see, every number except for the lucky number was printed out in the console. That's that regarding basic looping. Next, I'm going to show you how to process arrays using loops and the enhanced for loop, which provides the simplest way for processing arrays. Remember when I explained how arrays work, I told you that you can access array elements by specifying the index of the element we want. Well, since loops have a counter variable, we can easily use that variable as the index for accessing array elements. Let's say we have an array of messages representing window events. I mean, it could be an array of fruit names or something like that, but it doesn't really matter. Here's how we would process it using a while loop. So we have our messages, string array, window messages is assigned, and then I provide some window event messages. Next, we need a counter variable. Int I is assigned 0, while I is less than window messages length. Then we print out each message by asking for the element of the array at the index of the counter variable. System out print line, processing window message, concatenated with window messages at the index I, concatenated with a double quote. Don't forget to increment the counter, I++. And lastly, we print out that all messages have been processed. We're using the counter variable I as the array index. This way, we write the loop one time and process all the elements instead of processing each element individually. Here's how we would process an array using a for loop. Now we'll have the counter, the condition, and the increment expression inside the parentheses, and everything else stays the same. This is a very effective way of processing arrays. Loops are the foundational concept of every programming language, and you will be using them extensively in your work, in one form or another. Since Java 5, there is an additional form of the for loop called the enhanced for loop, which can only be used with arrays and collections. With the enhanced for loop, you don't have to specify the test condition or iterate a counter variable. Instead, you only tell it what array or collection you want to iterate over. Here is an example. So let's say we have window messages just like the last time. Here we're basically saying for each message in window messages, do this. For string message of window messages, and we print out processing window message concatenated with message. And we print out that all window messages are processed. As you can see, this is cleaner and more readable than a conventional for loop. This is the loop you will be using most of the time in Java because whenever you need to iterate over a collection, this is the cleanest and most readable way of doing so. At some point, you are going to learn about collections and streams, which are much more powerful for processing data, but keep in mind that they all use loops under the hood. So far, we've been writing all our code mostly inside the main method. While this simplifies things when teaching and learning, it doesn't represent how we would write code in a real-world project. In real-world projects, we deal with complex business logic all the time. To make it manageable, we break down this complexity into smaller pieces, making the code easier to understand, maintain, and reuse. One of the primary ways of breaking down and organizing complexity in Java is by using methods. You've noticed that every time we called a method, we've referenced an object or a class. This is because in Java, all methods must belong to classes or objects. This is how business logic is represented in Java. Classes are used to represent real-world objects, while methods represent the behavior of these objects. So, in Java, developers should strive to extract certain behaviors and actions into methods, which can be reused. Let's see an example of method extraction in action. Let's say we have a program which calculates the total cost of an order. So we have some items, but we only represent their prices. We have the weight of the package. Double weight is assigned 5. Now, first we have to calculate the subtotal amount. We initialize the subtotal variable as 0, and then we go through all the items and we add their amount to the subtotal. We can have a discount. Double discount is assigned subtotal times 15 divided by 100, which is just 15%. Then we need to calculate the tax, for which we have a condition. If subtotal is above 100, we also apply a fixed tax of 2. Otherwise, we only apply the calculated tax. We also have a shipping fee, which is higher if the weight is above 5, double shipping fee if weight greater than 5. Shipping fee is assigned subtotal times 7 divided by 100. Otherwise, shipping fee is assigned subtotal times 5 divided by 100. And then we calculate the total. Double total is assigned subtotal minus discount in parentheses. Then we add tax and shipping fees. System out print line, your total is total. This is a neat little program which calculates the order total. However, it's not easily reusable. If we wanted to calculate the total, tax, or shipping fee in another place of our program, we would have to copy and paste this code. This is bad because let's say tomorrow we decide to change how tax, shipping, or something else is calculated. We would have to track down every place in the program where this logic was copy-pasted. Such code would be difficult to maintain and is prone to errors. However, we can easily solve this if we extracted the calculation logic into methods. If we had methods for calculating tax, shipping, and other parts, it would be easy to reuse them across the program. And making changes is also much easier because if we needed to update something, we can simply change the method definition, and anyone calling this method will be affected by these changes. Another great thing about methods is that they are parameterized, meaning each call of the method may receive different parameters, allowing us to customize the calculation logic while still preserving reusability. Let's refactor this code and extract the calculation logic into methods. So we'll create a new method, calculate subtotal, and it will accept an array of doubles which will represent the item prices. Then we'll take the subtotal calculation logic and use it in the method. At the end, we return subtotal. We do a similar thing with the discount calculation. Create a new method, calculate discount, but it will have two parameters, the amount and the discount percentage. And then we say double discount is assigned amount times discount percentage divided by 100. Return discount. Then we have the calculate tax method, and it also has two parameters, the amount and the tax percentage. And we just rewrite the logic from the main method here, and we return tax. Finally, we have the method for calculating the cost of shipping. Also has two parameters, double amount and double weight. And we just repeat the logic from the main method for calculating shipping. And at the end, we return shipping fee. Alright, now we can call these methods in the main method. Double subtotal is assigned calculate subtotal, and we pass it items. Double discount is assigned calculate discount, and we pass it subtotal and 15 to indicate we want 15% discount. Double tax is assigned calculate tax, and we pass it subtotal and 25%. Double shipping fee is assigned calculate shipping, and we pass it subtotal and the weight. Look how clean and readable that is now. You can tell at a glance what this program does, and it's all reusable. Hey there! You've made it to the conclusion of this video, and I appreciate your dedication to learning. If you found this content useful, I would appreciate it if you supported me by liking and sharing this video and subscribing to my YouTube channel. Don't forget to enable all notifications to stay updated on future uploads, otherwise YouTube may not notify you properly. For those keen on delving deeper into Java, I recommend enrolling into the full Java Fundamentals course, which expands beyond what you've seen in this video. I've shared 2.5 hours of the course content for free, but if you're serious about becoming a professional Java developer, I encourage you to enroll into the full course. I've left a link in the description of this video if you're interested. Thank you for watching, and I hope you have a pleasant day.